Now let us start the next class. Today's class we are discussing about vibration damping and stringing chart. Vibration damping. You can look at the diagram. The galloping cannot be restricted, but the aeolian vibrations can be restricted using the vibration damper. A damper used to restrict aeolian vibration is called Stockbridge type damper. You can look at the diagrams too, friends. It consists of a steel cable. At the two ends of the cable, two hollow specific shaped weights are fixed. At the midpoint, the damper can be fastened to the conductor by means of aluminum clamp. So can you see that? The weights used are of galvanized iron. The main feature of this damper is the grip of the damper. The conductor uses only one bolt. Another feature is that these dampers can be fastened to the conductors even though the line is alive using the special long-handled tools. You can see the complete arrangement of the Stockbridge type damper. The special shaped weights actually act as dampers. These dampers will act as a concentrated mass at a single point on the conductor. The vibrational energy due to the hysteresis and interstrand friction gets absorbed by the damper. Due to this absorption of vibration wave energy, the first vibration itself gets damped before the amplitude of the vibration becomes very significant. Got it? Thus, aeolian vibrations are reduced by the use of dampers. Depending upon the span and the size of the conductors, the number of dampers and their locations are actually selected. What are the factors, by the way, affecting the conductor vibrations? That is very important to know. The various factors, those are, one is atmospheric conditions like icing, rain, and high wind velocities, so many. Span of the conductor also will affect, tension in the conductor will affect, and also you cannot ignore conductor configuration. That's also design is very, very important. Types of clamps, what we use here, that was also important, which affects the conductor vibrations, and height of the towers, that also affects, conductor vibrations. It adds to that. Number of dampers and spaces used and their locations, everything matters. Some other factors depending on electrical and electromagnetic phenomenon like corona. These are all the factors which affects the conductor vibrations. Now let us move on to the stringing chart. You can see here the stringing chart. The stringing chart is actually very useful to find the tension and the sag at any temperature and the loading conditions, when these values at any other temperature and the loading conditions are known to us. Okay, that is very important. In some cases, instead of tension T, tension is denoted by T, sag is denoted by S. So here, tension T, that is in here vertical one, that is y-axis represents tension in T. This side, right side, y-axis represents sag in meters. Horizontal represents temperature in degree centigrade. You are looking at the diagram. So in some cases, instead of tension T, the stress F is plotted against temperature as an independent variable. Knowing the area of cross section, we can the tension T can be obtained. We can find the tension T, knowing the value of F from the stringing chart. So instead of solving the graph of tension in kg against temperature in degree centigrade and the graph of sag in meters against temperature in C, such graphs actually is called as stringing chart. The stringing chart, what you are seeing here, the diagram, the graph itself tells us how the values can be picked from the stringing chart. That corresponding sag, T, and temperature, for what temperature, what will be the sag and what will be the tension. It will be denoted and it can be calculated or it can be extracted. The values can be obtained easily by stringing chart. So today we have discussed about dampers and stringing chart.